Well, today my topic is about selectivity shown in nanochannel, which is inspired by nanochannel and nanofiltration reported by Dr. Yang Lan from Department of Research, UCL. So first part is summary. In conclusion, the aim to study nanochannel is due to the different performances of fluids in channel with diameter between 1 and 100 nanometers comparing to the traditional fluid mechanics. And then we go to introduction. As the size of channel approaches the nanometer scale, the channel wall might bring charges. Hence, the channel wall attracts the counter ions and rejects co-ions at a very close distance. So that's the first layer called stern plane. More distant away from the channel wall, the attractions to counter ions are weaker. Hence, the concentration of counter ions and co-ions absorbed by the channel wall gradually became neutral. So that's another layer called shear plane. So the combination of stern plane and shear plane is called electrical double layer. So that's EDL. As the charges around the channel wall gradually become neutral and the electrical potential decreases. The distance from the channel wall when the electric potential decay to 1 over E of its original potential is called debye length. So this is debye length. And we might find that the description of electrical double layer and debye length are so similar. Hence, we use the debye length to approximate the thickness of EDL. The debye length depends on the concentration of salt in surrounding, as well as the temperature and dielectric constant, which is a ratio of permittivity of a material and that of vacuum. So if the size of channel is much bigger than the debye length of that material, just as this picture shown to you, all kinds of ions are able to navigate the channel. However, charges are not distributed evenly around the channel wall due to the electrostatic force. While the central area still shows electric neutrality, counter ions concentrate at the edge, which is closer to the wall. If the size of channel is closer to the debye length, in other words, the whole section of channel is affected by the electrostatic force, hence shows strong ion selectivity to the counter ions. So if the size continues decreasing, ion selectivity is enhanced and almost all co-ions can be filtered off. And finally, we go to the application of ion selectivity. So that's various. Today, we only focus on the part A. For example, many areas that still have problem with getting drinkable water. We may utilize the ion selectivity for several times to filter off the impure ion, like sodium ions or chloride ions. And at the end, thank you for your listening. And I have to claim that the part of explanation comes from the Wikipedia and ChatGPT. Thank you.